Hey there, it's Miss B, and in this video we are looking at the Mid-Unit 5 study guide. So this is for Unit 5 of Illustrative Math Algebra 1. So you are to not use a calculator. So we will do this without a calculator, at least for this question or for this part. So these equations represent the number of people infected with 4 different flu strains as a function of time t in days. We want to determine if each equation represents growth or decay. So in order to determine if it represents growth or decay, we want to look at the growth factor. So that is going to be all of these numbers in our parentheses here, but it's really any of the numbers that has the exponent on it. So I'm just going to highlight all of those. I'm looking at this number on everything here. If that number is bigger than 1, it's going to represent growth. And if it's smaller than 1, it's going to represent decay. So that means for our first one here, this is going to represent decay because it is 1 over 6, which is definitely smaller than the whole number 1. So this is decay. 3 over 2 is larger than 1. So it is going to represent growth. Anytime you have the bigger number in the numerator, that is a sign that it is larger than 1. 1/2 for this one is definitely smaller than 1, so we're going to have decay. And 4, definitely a number bigger than 1, so that's going to represent growth. So now for part E of this question, we want to know which equation represents the population with the greatest growth, and then explain. So the one with the greatest growth is going to be the one with the largest growth factor. So I would say V of t, because, make my handwriting more legible here, because 4 is the largest number for the growth factor, so it has the biggest growth factor because it has the largest growth factor. And then to clarify, we can say that 4 is greater than 3 over 2 because that was the only other one that represented growth. For part F, we're asking which equation above represents the population with the greatest initial population, and explain. So for the greatest initial population, we're actually going to look at the initial value, which is not the number that has the variable on it, but it is the other numbers here. So the 250, the 10, the 100, and the 3. And so the biggest out of these is 250. So our answer is going to be that first one. We are going to say that R of t, because 250 is the largest initial value. Okay. And then the last part of this one is which equation above will have the greatest population infected after 5 years, and explain. So even though 2 of these represent growth, so we're going to have some of them decaying and some of them growing, this answer is actually going to be V of t. So it's going to be the one with that largest growth factor. And the closest other one is not really going to come closer. So you would say V of t. And you can find these by plugging things in. But if we're asked to not use a calculator, which they asked us to not use a calculator, I'm going to say V of t because it has the highest growth factor. And so even though there is another one that is growing, it's 10, but it's only growing by 1.5, and 3 times 4 every time is going to really, really quickly pass it up. Okay, so let's look at question 2 here. This is 11 question assignment, so it might be a bit of a long video, but be worth it for your test. So, a study was conducted to analyze the effects on a deer population in a particular area. Let f be an exponential function that gives a population t years after the study began. If f of t is a times b to the power of t, and the population is increasing, we want to determine if each statement is true or false. So I did just say, or see, that they said the population is increasing. And in this case, we have a for the initial value, right? Because that's our number here. And b has the exponent attached to it, so that's going to be the growth factor. So if it's increasing, I know that it is true that b is going to be greater than 1. And then it would be false that b is less than 1. Now, this is then talking about the rate of change for C and D, that the increases in the first few years are less than the increases in later years. And if we have exponential growth, we kind of start slow and then eventually grow higher. So that seems to be true with this one. That would follow that pattern. So if that's true, and I'll erase my little sketch, then the population's increase for the first few years being greater than the later years, that is going to be false. And then for this very last one, a does need to be greater than 0 because we cannot measure a deer population if they start with 0 and a was the initial value. So if we move to question 3 on the back side here, we want to determine if the graph is one of the following. So we have options increasing and decreasing with linear. So increasing linear, decreasing linear, and then exponential growth or exponential decay. So it's really just about, can we identify which is which? So for this first one, this is linear because it's a straight line. And since it is going up from left to right, this is going to be increasing linear. I'll use my thinner marker. Okay. For B, this is definitely exponential, but we have to decide, is it growth or decay? And since it's starting up higher and then it's going closer to 0, we're going to say it's exponential decay. For our third one, this is exponential again, but it's going the opposite direction. It's starting slow and then it's gaining speed. So this is exponential growth. Okay, let's look at these last 3. This one here looks just like the one we just talked about. So this is also going to be exponential growth. Number E, or letter E, I guess, this is linear because it is a straight flat line, but it is decreasing because it is going down from left to right. It looks like it's going downhill, so this is decreasing linear. Okay, and the very last one here, this is exponential again, and it still is going down from left to right, so instead of saying decreasing, it's exponential decay. Okay, and that is all of question 3. So let's look now at question 4. We have a population of butterflies that is starting to migrate to a new location each week, or new location. Each week, 1/5 of the population leaves the beginning location. Below is a table that represents the population. Which equation shows the number of butterflies B after each week W? So they're giving us a table and they just wanted us to identify which one here matches up. Well, I can look at week 0 for my initial value. So I know it's going to be 10,000. Looks like it's going to be one of these two, because it would not have 10,000 with the exponent on it. So we can say it's definitely not this one. And we know that with exponential growth and decay, we don't use a plus. Now, if we have 1/5 leaving, that means we have 4/5 left over. So 1/5 of the population leaves. That means we start with the whole amount, or 5/5, and we're subtracting the 1/5. So what's left over is 4/5 for our growth factor. So the answer for this one is B. Question 5 here, we have Carly buying a bond as an investment for the future. The table below shows the value of the bond over a 3-decade time frame. Write an equation relating V, the value, to D, the number of decades since it was bought. So I'm going to say V of D, just because they want me to write a function relating those two. And I can say that it's equal to. Now I'm going to look for my initial value, which is going to be 250, because I see it right here in the first column. And then the second part is to look at what is happening each step. Here it appears that it's multiplying by 2. I can check each time. It is multiplying by 2. So we'll have 2 and then to the power of D. Sorry about that. Lost connection to my iPad, or from my iPad to my Mac. So we're going to finish this just filming on the iPad. So now you can see all of my UI here for my for my app. But so this would give us 64. And then if we did -3, all that would do, if we had h of -3, is it's going to actually flip our, it's the same as if we flipped this upside down and we had 5/4 to the power of 3 instead. So what happens is we still are going to get those same numbers, 125, and we would have 64 instead on the bottom and 125 up top. But we actually do have to plug that one into a calculator to simplify it. And this would be, I believe, 200, and it comes out to 244.14. So these are my two answers for part A. So, and it does make sense, because as we go backwards, it should be getting larger. If going forwards, it's getting smaller. So part B says, then what does h of -3 mean in this situation? Does it make sense? Why or why not? So now we want to make sense of this. It's the height of the ball in inches after n number of bounces. So this would be height of the ball after -3 bounces. So we're going to say, no, it does not make sense. Because I have to give reason here. We'll say it does not make sense because, like, you can only have 0 or positive numbers. Bounces can only be 0 or positive numbers. Okay. So question 7 is now asking us to write an equation for the following situations. And it does give us the warning that some of these are linear. So Samuel has $2,300 in his bank account, and every month he adds $200. We want to write an equation where m is the number of months and the total dollar amount for a certain month. So this one is going to be linear because he is only adding a certain amount. So I am going to say that his dollar amount is equal to the $2,300 plus 200 every month. So D equals 2,300 plus 200M, and that is this one. So it's linear. Now with the next one, Sue planted 5 trees last year. Her goal is to triple the amount of trees she plants every year. So this is going to be exponential. Write an equation where T is the number of years and N is the number of trees. So N would be equal to the number of trees last year as the initial value, tripling, and then T is the number of years since then. Okay. Then question C, Carlos has $2,500 and loses 1/3 of it every month due to bad boy habits. That's a weird way of phrasing that, but okay. Write an equation where M represents the amount of months since Carlos had $2,500. So we're going to use M represents the months and R represents the remaining. So the remaining amount of money is going to be equal to his starting amount. But if he's losing 1/3, that means he's keeping 2/3. So we're going to have to the power of 2/3, and then M is the number of months. Okay. And then for D, Sharon has 2,000-piece puzzle. She said put together 50 pieces every night before she went to bed until the puzzle was complete. D is the number of days. And does it say I? I represents, you know what, we'll just say, we'll say P represents the number of pieces here just because I is such a weird variable to use there. So P represents how many pieces she has left based on the day. So P is what our output is going to be here. And that is based on the 2,000. But she is putting together 50 pieces. So we're going to lose 50 pieces of that every day because they will have been assembled into the puzzle. So this is like her remaining amount. And that was question 7. We only have like a couple more, so stick with me here. We have the table below represents an exponential function. So we're going to complete the table. Our pattern here is that we are multiplying by 4. And it still works that it's multiplying by 4 here. So we're going to continue with that and multiply by 4. This would then give us 192. From there, if we multiplied by 4, we would get 768. Then we would get 3,072. And then we would get 12,288. Now they want us to write an equation to represent the table. So y is the output value. The initial value is actually the one that happens at 0. So our initial value here is 192 with a growth factor of 4 to the power of x. And that brings us to our last page. We're almost there. 10 and 11, we can use a calculator, but we can use some basic arithmetic calculation, I guess, for some of the other things here. For equation y equals 135 times 1/3 to the power of x, complete the table and plot the ordered pairs on the graph. So we are dividing each part here as we move forward, but the 135 is what's going to start at 0. So if we divide by 3 each time or multiply by 1/3, then that's going to be 45, and then 15, and then 5. Now going backwards, we would have the effect of multiplying by 5. That would give us 405, 1,215, and then 3,645. So from here backwards, it is multiplying by 3 instead of 1/3. If we graphed that, it would look a bit like this. We would estimate at 135 right about there. And then moving forward to 45 and 15 and 5, basically at 0 almost. And then if we go backwards 1 or 2, 405 would be like here, and then 1,200 up here, and then 3,000 is going to be off of our graph, so we can just kind of connect it like this. Questions 10 and 11 you can use a calculator with. So the number of people infected with the flu virus is represented by this equation, 125 times 3 to the power of d, where d represents the day since the flu virus was discovered. What does it represent in context, and what about the 3? So what does the 125? 125 is the number of people originally infected. The 3 is how fast it is spreading. So how many people were infected on day 6? We would want to plug this into our calculator. So we are going to use f of 6, and this would be 125 times 3 to the power of 6. And when we plug that into a calculator, we get 91,000, not a 6, 125. Is it possible to have day -2? Yes. Yes, it is, because that would be 2 days prior to this. And I'm sure there were people originally, before it was actually discovered. So yes, 2 days before it was discovered. How many days before it passes 20,000 people is the next one. And so you could actually crunch your numbers here by plugging them into a calculator, but that amount is going to happen on day 5, because day 4, if you plug in for 4, you will get 10,125. And if you plug in for day 5, you'll find that we now have 30,375. So now we're on to our last question. The amount of money in a trust fund for a child is represented by $20,000 times 2 over 3 to the power of m, where m is the month since the child gets access to the fund. So what does the 2,000 represent, or the 20,000 represent, and what does the 2/3 represent? 20,000 is the original amount in the account. The 2/3 is how much is left, and this was each month. So this means they are spending 1/3 of the money. So how much is left in 4 months? That just means we plug in 4. So this is 20,000 and 2 over 3 to the power of 4. When you plug that into a calculator, you get 3,950.62. So that is it for our whole assignment. It was a very long one. I appreciate you sticking with me, and yeah, good luck on your test.